Okay, question 6H2 from the second edition of Statistical Rethinking. Make sure that you have used these first two code blocks up here to install and load the Rethinking package into R. And where are we? Okay, so 6H2 references question 6H1. So let's look at question 6H1. In question 6H1, we were meant to look at the waffle divorce data set and then come up with a DAG, a causal model, of how we believe that, that the number of waffle houses is affecting divorce. Okay, so if that sounds unreasonable to you, that the number of waffle houses would affect divorce, I agree. And I think that for the sake of this question, we are just meant to assume that that's a reasonable hypothesis. Okay. Now, whatever your DAG was, so we can all have different DAGs, different models, and that will change really all of the answers here, but they should, hopefully you can kind of walk through my simple example and help you on your own. So the DAG that I came up with was that waffle houses directly affect divorce, and that southernness, the feature of a state of being in the southern United States, affects both the number of waffle houses in that state and divorce rate. Okay, so this was my basic DAG. All right, so here in 2, we need to test a series of models to kind of check the validity of our DAG, the DAG that you just saw. Okay, and it suggests that we use implied conditional independencies. And so if you remember what implied conditional independencies are, this is when we take variables within our DAG, two variables that begin as being dependent, generally, but then become independent once we condition on a third variable, or at least a set of variables that are not the two that are dependent that we're testing. Okay, and so if I go up and I look at my DAG here, let's try to find some implied conditional independencies. Okay, well, if you look through this, you realize that there's none. Okay, every variable is connected to another variable by a direct path, right? And so there's nothing that we can condition on to get rid of these dependencies. Okay, so like D and W, according to my DAG, maybe not in the data, but D and W are related, and the only other variable I could condition on is S, but conditioning on S will not remove the implied association between W and D. Okay, and similarly for S and W, the only one I can go to that I can condition on is D, but that's not going to change the relationship between S and W. And for S and D, conditioning on W is not going to somehow break up the connection between S and D, at least the direct path. Okay. Now, if we were unsure about our conclusion, of course, we could always use the implied conditional independencies argument from the DAGity package, right, which I've already loaded up here in question 6H1. Okay, but if I use that, you notice that nothing comes down below, right? So I run this again, and nothing happens. And the reason is because there are no implied conditional independencies. It would be nice if that command said none or something like that, but this, when it just does nothing, you can't tell if it did what you wanted to do, but there's none. Okay, so now we have to come up with other ways of testing the validity of our model, right? So one way that we could do this is we could go through each of the relationships in our DAG, okay, and I could build a linear model for each relationship without conditioning on the other variable, and then bring in a complementary model where I am conditioning on the third variable. Okay, so if that sounds a little bit confusing, we'll go through it in the code, and so. Okay, so here it is. So in previous examples, and I think probably chapter 5, we have wrapped all of our, we have used Bayesian models, and we have wrapped it all into a single large model that just happens to contain several smaller linear models, and that's probably the better way to do it. But just for variety, I will here use the linear model function, the LM function in R, which is a frequentist-based approach. Okay, and so I have several regressions here, right? I have one for the divorce being regressed on Waffle House. Actually, you know what? Let me. I'm going to put the DAG up here so we can see what's happening. Let me pause this. Okay, so I've just used a draw DAG command with the DAG that I made in 6H1. Okay, so I have one linear model here that regresses divorce on Waffle House, so it would be this bottom arrow. Okay, or it's trying to represent this bottom arrow without conditioning on S, right? It just ignores that S even exists. I have another linear model for southernness to divorce, right? Divorce is being regressed on south. Okay, so that's this without conditioning on W. And I also have a linear model for S and W, so I'm regressing Waffle Houses on the south. Okay. Now I need another model that actually conditions on an additional variable. Okay, so here I have divorce is being conditioned or is being regressed on Waffle Houses and the south, right? So now I have I'm looking at both of these arrows, but I'm conditioning on the other variable, right? So I hope that that's making sense here, right? So this last one is kind of like a combination of the first two regressions, okay? And so I'm going to run that, and then I'm going to pack everything into a data frame. This is kind of an ugly way of doing this, but that's okay. So let's go through this. Okay, so again, I've recreated the DAG here just for ease of visualization. Okay, so first let's look at WD. So we're looking at this relationship in the unconditional model. So in other words, the model where we have not also included S, right? So so the estimate of this relationship is here. It's not very strong, okay? And then we have a p-value here that is reasonably low, right? Now, I know that in frequentist statistics, it's often, you know, p of less than 0.05 is significant, and then anything above that is non-significant, and there's all sorts of philosophical issues that we won't go into here. But let's just say that this is a reasonably low p-value, and so it suggests maybe some evidence that this arrow here exists, okay? But now I'm going to look at the conditional model. So again, the conditional model is this big model with both Waffle Houses and south being explanatory variables. And we notice that now this apparent connection between W and S is diminished. And also the evidence, the p-value, the strength of the evidence summarized in the p-value gets much weaker. So a high p-value generally means weaker evidence, okay? So by conditioning on S, this apparent connection seems to have dwindled basically to nothing. Nothing would be a good estimate of this relationship, of the direct relationship, right? And so that suggests that maybe this arrow is an inappropriate arrow, okay? So already this DAG has a mark against it, but let's look at some of these others. So we have south affecting divorce, okay? So now, so we have the unconditional and the conditional model. So the unconditional model would be this model right here, right? Where divorce is just being regressed on south, okay? And we see that we have whatever the estimate is, okay? We have whatever the estimate is, and with a very low p-value, so very strong evidence. And then when we also additionally regress on W on Waffle Houses, the estimate doesn't change that much, although the p-value does rise considerably here. This is still reasonably strong evidence for a connection here, but not super strong. And so how we interpret that is a little bit of a mystery. It could be that there are additional variables that are confounding these relationships here that we would need to think about and possibly incorporate into the model, okay? So just to recap up to this point, this first relationship here seems to have blown our initial DAG out of the water, as we probably expected. The second one is a little bit ambiguous. We're not really clear what is being said here, but possibly the fact that the estimate changes as well as the strength of the evidence of that connection suggests that there may be additional variables that we need to consider in here. And now finally the S to W model. So this this relationship right here, we're not conditioning on D because D is our outcome. I guess we could, but we do get an estimate for the strength of southernness affecting the number of waffle houses. Okay, and it's very, very strong. Okay, and so when we take all of this together, a better DAG would be basically just south affecting W and D without W affecting D, right? Right, because we have a lot of evidence for south affecting waffle houses. We have pretty strong evidence for south affecting divorces, and we have almost no evidence that W is affecting D once we account for southernness. And so all of that implies this fork structure on southernness. Okay, that's it.